Okay, welcome everyone to the UC Davis Western Center for Agricultural Health and Safety April Seminar Series. I'm going to go ahead and get started with our opening. If we can go to the next slide, thank you. I have a few housekeeping items. First, the seminar is being recorded and all participants are muted. I'm going to jump quickly to the interpretation. Please go ahead and select the globe icon below for interpretation services. If you would like to listen in Spanish, please select the Spanish icon. And if you'd like to listen in English, please select English. You can also use the chat function throughout the seminar for questions, and we will have a Q&A session at the very end of the presentation. We have closed captioning available, and to use this, you can select the CC icon below and click Show Subtitle. For those of you new to the seminar series and to the Western Center for Agricultural Health and Safety, welcome. Our mission is to improve the health and safety of agricultural workers in the West through innovative research, interactive trainings, and tailored outreach. And so this seminar series is an example of us translating research and outreach activities through presentations to the wide audience of agricultural stakeholders, community members, policymakers, and researchers. And so we're happy to have you here. We're here every Monday, first Monday of the month, and thankful for some sunny skies on this first Monday of April. Today, I'm really happy to be able to introduce our speaker, Dr. Salah Issa from the Department of Agricultural and Biological Engineering at the University of Illinois, Urbana-Champaign. He'll be presenting on findings from a recent conference and gathering that was held back in November, I believe, that discussed the safety for emerging robotics and autonomous agriculture. It was a workshop that brought together folks from across the country to discuss a very important and emerging topic that is certainly relevant for all of us here on the West Coast. So with that, I'm going to turn the floor over to you, Salah.
Thank you very much, Heather. And let me share my screen. Can everybody see my screen? Okay, I got the thumbs up. Well, welcome everybody. Thank you guys for coming here. My presentation here it's about the findings that we found for our Safer Ag workshop. That's our acronym for the whole thing. This is something I'm presenting, but this presentation, it's coming from our whole team, including from UC Davis. We have Farzana, and we have team players across the US working on this. Just to do a quick outline, I'm going to start with a quick history and future of automation. Then I'll go and focus into what is this Safer Ag workshop that we hosted. And lastly, but not least, what are our findings from this workshop? So it's really important to start with a kind of like a history, you know, all this new technology that we're seeing, all this autonomy that we're seeing in agriculture, it's a long line of automation that, you know, we keep reiterating, we keep growing, we keep moving forward. It's really important to understand that future from that perspective of the past. And it's a really long history. So this is one of the first tractors that first ever came out. You can notice that it did not have rubber wheels, right? That came later on, and it really evolved very slowly. The first tractor to come out was in 1892, and at that time, you know, as the tractors were coming out, we saw that transition from animal to machine power. That transition really lasted about around 60 something years. It was until 1954 that the number of tractors on a farm were greater than the number of horses. So it's really important to notice that this transition took a long period of time. And when it comes to autonomy, it comes to the future, we're going to see a similar transition period as well. And this, the first initially we had steam engines. That's what ran our tractors. And then later on, we moved to internal combustion engines. That's when we saw a lot of this massive improvements we saw. We talked about steel wheels becoming rubber wheels. That was really only until the 1930s. In the 1930s, like all tractors had steel wheels with lugs basically jutting out of them, kind of like we saw. And while those tires, they provided good traction in the field, they rode very roughly and really ruined the roads. So it was so when they finally invented rubber wheels, that gave them more power, gave them better gas mileage, kicked up less dust, and became more comfortable for the farmer to drive. Similarly, the first power transfer that also occurred in that around the same time. If we look at the American Society for Agriculture and Biological Engineers, their first standard for PTOs was in 1927. So you can see that transition. When it comes to our safety perspective, the fatalities, the injuries from tractors, we don't see a lot of push until the 1960s. That's when we see a lot of messaging from the perspective of safety, and standards are focused specifically on safety. That doesn't occur really until the 1970s. That's where we see both ASAB standards and OSHA standards for tractors. And as this technology was taking root in agriculture, there was a lot of pushback. Concerned farmers, concerned families. There's a lot of injuries and fatalities that occurred, and other safety concerns that were slowly being dealt with and addressed. For example, this is provided by my colleague John Chusky from Wisconsin. In 1943, there's 166 farm fatalities in Wisconsin itself, and the vast minority of them were involving animals. The rest were basically mechanization was taking over in terms of safety concerns. Now, the seeds for autonomy, in a sense, what we are talking about now, really began, I would say, in about the 1960s, right? So that's when we started having these simple tools that basically monitored the seed dropping, the shafts rotating. That's when we started seeing GPS. Was gradual. First, it was to monitor yield, then mapping, then trying to tackle that variable rate. We started seeing out of steer and guidance. That's when we started to see also app controls and self-diagnostics come along. And that's basically when we moved to full-scale automation, and then also we're starting to get into autonomy. So it's just important to give that perspective that this is just a time scale. This is a slow but steady progress of evolution of technology. And now we're entering, in a sense, the next phase. All of these videos and photographs were captured either by John Frisana or I when we went to the FIRA conference last October in Fresno. So this is a small robot, autonomous robot that can do multiple things on its own, including plowing and so on. And that's actually one thing really cool about this next scale of technology. It is that spectrum of technology that's coming up. It's no longer large scale tractors. We're really seeing equipment at any scale and almost any job in agriculture. And that is something, for example, these two graphs are provided by the Mixing Bowl Hub, kind of highlights that. So if you look at both livestock and the next pictures for agriculture, you can see it's really covering the gamut, from livestock health to management to operations. And you have, whether it's milking robots are cleaning our sheds and barns. It's just covering the whole gamut of technology, which is really, really cool. And it's growing rapidly. There's lots of players in this market. which is very exciting, but it also raises our questions about how are we going to maintain a safety standard in a sense. So you see a very similar trend with crop robotics landscapes. Actually, there's a note that some of our smaller startups are starting being bought up by the older companies, but very similar. You see it's covering the gamut from basically from autonomous movements to crop management to harvesting and all the way through the scales, whether it's just sensing, whether it's actually harvesting, whether it's planting, whether it's weeding. It's really, it covers the whole spectrum. And these robots are coming at all scales, from small to large, at all price points. So what we're seeing in the next coming decades, it's really transformative. There's a study conducted recently that found that 80% of the technology that's being researched for agriculture is still not in the fields. And that is something we also saw at FIRA conference. So just to give you a sense of these technologies, I'm going to just go through some of them that we saw at FIRA. So this equipment here in front of you, they call it GUS. It is a sprayer for orchards. It has a GPS, it has LiDAR, it has wheel encoders, steer angle sensors, spray system monitoring. From a safety perspective, their front bumpers, it's designed to be touch sensitive. So anything touches the front bumper, it will stop. You set up a geofence. That's what you see in that commuter monitor there. It has also cameras. And in terms of productivity, it's pretty insane what it can do versus what we used to do, right? So in conventional system, in a large operation, usually you'd have maybe 12 conventional, 12 tractors, 12 sprayers, 3 trucks, and 15 workers. And now that gets truncated tremendously down into just 8 sprayers and, more importantly, 3 workers. So that's really cool from the safety perspective, because in a sense, from this operation, you're reducing the number of workers that are exposed to these chemicals. So that's, in a sense, one technology that's going on at large. And also to show you at small scale, they're saying even at small scale levels, their technology is still worth it. You reduce it from 2 workers now to just 1 person. That's something that a farmer would be excited at. It's very hard to find labor. It's very hard to divide your tasks and so on. And these systems like this GUS thing, you're not driving it, as you can tell here. There's no place for the driver, right? Your worker, he's just situated in a truck that's at the beginning of that field, and is manually operating this GUS equipment. And when it needs to come back, that's when he refills it. And what's really cool with this is that as it's spraying, he can go fill his tank and come back and be ready for the next time. It reduces, in a sense, it reduces downtime, the downtime to refill the tanks from 45 minutes usually to down to 3 minutes. So it's a really, that's just to show you one perspective. And this equipment, by the way, it's already being manufactured. It's already on farms, about 200, they have around 200 units in operation today, whereas with the last, as I know. Another one is a laser weeder. So this is by Carbon Robotics. So what this was developed in 2018, fairly recent. They only have 10 in the field, so they're just starting up. And what this does, it shoots this high intensity laser onto the weeds and just killing them like that. It can basically cover up 2 acres per hour and kill up to 200,000 weeds per hour. they say that it has a kill ratio of up to 99% of those weeds. And that its capacity to find out what a weed is if I remember correctly, when we talked to him in person, it was around 80 something percent. So here, actually, let me show you, in a sense, a video of it. So you can see it. Figure out what the weeds are. You can see some of the burn spots, so they're the ashes of the previous weeds. Now, one thing that they did tell us in demonstration, that that amount of flashing and lighting, that is more for demonstration purposes, just so that we could see it. They wouldn't ramp up the power all the way up, because it's not necessary, in a sense, to kill the weeds. There we go. A third example is our Neo. So this is, so you saw in our previous examples, these are very specialized equipment, right? That the laser weeder, right, can only be used for weeding. That's it. Our gust sprayer, it can only be used for spraying. So you have other companies that are coming from the opposite perspective. They say, hey, this is, having all this equipment, while it's cool, it's not going to meet the needs of the farmer. We need something more versatile. So this is Neo's one of those equipments. This is a Rio. So you can see their standard equipment is just basically this frame, kind of like a cab in a sense almost. And then in the middle, they put their different types of equipment. So they can put discs, they can put sprayers, they can put quite a lot of different modules inside that handle and address the needs of the farmer. And from productivity, they're 1 acre per hour. I don't remember if they said they're live yet. I don't believe they are, but don't quote me on that. But they have basically laser, they have bumpers similar to Gus, where they're sensitive to touch. They have GPS guidance as well. And I do believe they might have LiDAR as well. So this is, in a sense, so actually one thing that was really interesting is that they were trying to do this demonstration for us. And they wanted us close to see how this machine is operating. So they ended up duct taping their sensor that can sense people and stop immediately, because they wanted to be able to run it. So that was interesting. Like, I understood where they came up with duct taping that sensor for demonstration purposes. Makes total sense what they're trying to do, but it did raise interesting questions and made us, from a safety perspective, and you see this in really in almost even in existing tractors and anywhere, like that disabling of safety features. How easy is it to disable those safety features, and what impact will this have? So that was 2 examples. A third example, going back to our orchards, it's this burrow, our harvester. This is actually pretty cool. This is also live. They have about 200 in the field. It was developed in 2017. And so this system is using computer vision, precision, GPS, and AI. And what it does is that you can set it up to follow people. So you can see this lady, she's walking, and it's just following her directly. And after it learns the route, what it can do, it can re-navigate that same route. So why does this become very cool is that you could send a harvester into the fields, the burrow will follow him. And once the harvester reaches the spot where he's harvesting, he can enable the burrow. And then as he fills up the burrow, he can press a button. The burrow will go all the way back to where it needs to go to drop off all the harvest, and then go back all the way to the harvester. So now, in a sense, you've increased efficiency. Your harvesters, in a sense, are these specialized operators that know how to harvest really well, know what to harvest, when to harvest, how to harvest. And now, instead of the harvesters having to go all the way back to unload, Now they can focus on that specialized job that they're specialized at. And then these burrow machines can do that manual labor of delivering the robot, delivering the harvest back to that central area. So they say basically it increases productivity between 10 to 40% for a harvesting crew. So given all those talks, and this is probably a lot of you familiar with this, is what are some of the themes that we're seeing with autonomy in terms of discussion, in terms of really from our safety perspective. So the two that we came up on a lot on is trust and really that variability in how people are approaching safety or risk. So for example, for trust, this goes all the way back to Cal OSHA, right? Just a few weeks ago, Cal OSHA again rejected Monarch Tractor's request to be able to test and drive their tractors in California. And a lot of it is going back to that. We don't know whether it's going to be safe or not. There's this incredible amount of work that needs to occur on a trust of different levels, right? You have industry and regulators, you have the adopters and the farm workers, and then you have the economics and ROI perspective. We talked about, I showed you that laser reader earlier. That is, when we asked them, that's around in the range of $2 million, right? For that single reader. So these are really very open questions, right? And it's really crucial to understand these questions. It doesn't take much to change public perceptions towards autonomy, right? This is, I would say, an example to this is flights. You know, we know that flights are safer than going in a car drive. However, it just takes one flight accident or incident that just completely switches people's perspectives. Similar to here, a high profile, memorable incident where a person dies or gets injured could have a huge impact on industry. And it's really, really important that need for data becomes a really, really important denominator. One thing is, I'll point out that we learned from their Safer Ad conference, we had a person come up talking about these machines that can clean these barns autonomously, and that they're going to replace a full laborer. So this company, they were happy. They bought one of these machines and they let go one of the laborer because they don't need it. But when they started putting it into the barns, they realized they still need a person to operate these machines, to set them up, to do all this type of stuff. So they actually did not get that labor efficiency that they needed. So that's another perspective of trust that needs to be figured out and honed in more deeply. The next thing is really that risk approach, risk assessment and safety approach. It's with these autonomous systems, it becomes really big. And it's not going to be just about stopping for that obstacle, right? If you have an autonomous tractor running into this field, and let's say it sees, I don't know, a squirrel, and it stops. Great, that's good. But now it stopped. How does that farmer interact with the machine? Does he have to go back, or where is those dynamics and figures? How does it run? How would these machines go around obstacles? So that is areas that need to be a lot of further studies. In addition, like how we do those risk assessments, a lot of the risk assessments, it needs data, right? Risk is a combination of probability and the severity, and in a sense also controllability of the hazard. But we don't have data for all these new machinery. We don't know how people are going to interact with these machinery. We don't know even how to get all this data. So that is a big thrown, in a sense, in autonomy. And then there's a question of standards, and a lot of standards are in the process of developing to be able to address some of these concerns. in a review that that was conducted by John Chusky and his team, they found out that 1 in 5 people that are involved in the design and manufacturing of these autonomy systems, they're not doing any formal or informal risk assessments. And that, and if you remember a few slides back, we talked about how big this field is, how many different players are. So there's a lot of concern on the smaller companies that they're, in a sense, they don't even know where to look for these standards to begin with. So given all this information, that takes us directly to our conference. So our conference occurred on November 9th and 10th. It was focused on addressing the safety questions. And we designed it specifically as a workshop because we wanted to bring a diverse body together to talk about this, right? We didn't have the solutions. We wanted to learn from each other. It was sponsored by USD and IFA, and we had a lot of partners across the US, and we had industry partners, governmental partners, nonprofits, and obviously academia. So the vision behind this workshop was to create this community of practice, right, around the issues related to agricultural autonomy and robotics. And so we set it up as a 2-day event with a high level of interactivity with participants. And the goal is to, out of this comes a list of priorities where we need to focus next. It was very well attended and very well received. We had high participation from academia and industry. We were happy also with our government participation. We didn't get as many farmers as we wanted. That's always a hurdle. We tried to set this up late enough in November that we can get more farmer participation. But sadly, during that week, that it was still harvesting week. Farmers were still harvesting. A cool thing also, we had over 15 states represented all the way up to Alaska, from Alaska to Florida. So that's always cool. And what we did when we hosted this conference, we focused on really 3 key areas that we wanted to bring our audience together to come speak about. The first is, how do we go about regulating risk, from regulations and standards and general questions on risk management. The second thing is that what kind of research we need in our occupational safety research. And lastly, what is that workforce needs? What is that societal implications? That's really big because, some of the weeders that we talked about, the companies that are designing these weeders, they say that each piece of equipment is going to replace 24 workers. So that's really crucial to understand how is that impacting our societies. So our day one, it was a set of presentations with panel discussions, and we had some live demonstrations of some of the autonomous equipment to give that sense of what's going on in this field. And our day two, we just split everybody. We told in the morning, we said, hey, we're going to give you all a set of questions. You're going to answer them, kind of like a brainstorming session. And then later on in the afternoon, we split them into 3 rooms. And now they had to take all that brainstorming together and put it into some sort of agenda, basically. So this is what we found for this. When it came to the area of risk management, right? The biggest thing that came across from all our players, whether it was industry, academia, or government, is that there's needs data. We need data. Risk assessments, as I mentioned earlier, it's about all risk assessment can be boiled into that. The frequency, how frequent an encounter occurs. What is that severity if you're exposed to the hazard? Will that hazard kill you? Will it injure you? So on, and how controllable this hazard is. So this data, we don't know this data. We don't have this data. There's no way to collect this data except with just years of exposure and documentation. But we don't want to wait for years. You don't want to wait until you have an incident to be able to understand the safety about this equipment. So some of the discussions around that is that, hey, instead of focusing on a surveillance data set, which comes very late and usually is incomplete and has limited usability, why not we focus on exposure data? All of these autonomous systems, they are already documenting, they have cameras, lidars, sensors. So they're documenting every single interaction that they're actually experiencing with a human. So why not use that data to basically preempt and understand those interactions with the people and the surrounding environment. And we can look at it, actions over time, the environmental conditions, location, their proximity to hazards. And maybe this is something that this type of data sets could be used to build this basically use case report that can be used to document the safety and hazards of this machinery. So that's one concept. Some of the hurdles to that is, this data already is there, but it's owned by all these companies. So who is going to aggregate this data? How are we going to do it in a way that's not anonymous, that is anonymous and allows the companies better capacity to share this data? Other things that we spoke about a lot was the role that engineering standards are playing risk assessment. They play the bedrock. They're the ones that define risk assessment. We have multiple standards in existence on that, and some are being actually developed at this day to reflect the new needs. And something the whole team, the whole community agreed that these standards should be given their time to develop, and that they should be what is basically informing regulation. And we've seen that in the past. A lot of the early OSHA standards, they're coming from consensus standards. But we also need to understand that standards will always lag innovation, right? Because innovation is the latest and greatest. So how can we make sure that standards, especially from the safety perspective, is keeping up? Also, we need to realize that big manufacturers, they know these standards. They're part of the committees developing these standards. They're in the weeds on these standards. They know what's going on. But we have all these smaller companies that might not even know that these standards exist to begin with. So how do you go about informing them on what standards to apply? And there's lots of standards that you could apply. So how do you guide them on what standards they need? How do you do that curriculum, that training, and that engagement on that? And lastly, but not leastly, for our new agriculture engineers and new agriculture techs, how do we incorporate these trainings on standard and so on through their education system, all the way from K to 12 and so on. So those were some of the topics and discussions from these areas. And lastly, but not leastly, on standards is that, can we do some sort of standard wizard? I don't know if you guys remember back in the day in computers, anything you apply it's like has an installation wizard and so on. So similarly, could we develop something, basically software that walks engineers through the standard applications and guides them to what they need to use? And I've seen this here locally in one of our teams, with these small robotics that we're working on. We were talking with the manufacturer, and we sent them initially a list of questions about the standard, and they were so confused. They said, hey, you need to simplify it. So we went down and we said, okay, we need to turn this list into either a yes or a no answer, and we need to only ask them on what is relevant to their system. And we went down from, I think, 40, 50, 60 something level recommendations down to just 8 that we asked them. So I think it's a missing step that we need to consider, especially for our smaller operators who are developing these unique forms that does not necessarily fit into these bigger buckets that we're usually used to. From the occupational safety and research needs, we need to have a better understanding on human machine interactions. Right? We need to understand it from not just a safety perspective, from cognitive, from behavioral research, and understanding how that relationship is when during maintenance or repair or user interfaces. Also, it's not, given that this is agriculture, it's not enough just to look at human machine interactions. We also need to look at non-human machine interactions, whether it's with animals, with vehicles, with other systems already in place, like an irrigation system. So this is all important things. And we need to, and they've realized that one of the key things is that logistical barrier with manufacturers to share their data. So it was kind of very interesting when we were in that meeting together. We had manufacturers saying, hey, we need government's help to get these machines on the field, and government says we need the data. And they're looking at academia. And so it's kind of this triangle. Each one is looking at the other. But that is something that's crucial, is to build those relationships between academia, industry, and government so that we can do this research. Another things that came out of this committee was very similar to what came out of risk assessment. We need to document data through autonomous vehicles. Here we call it near misses, but it's really the same concept as we mentioned earlier. It's all those case uses and all those interactions that we're documenting. When it came to workforce and genocidal implications, there's a lot of questions on what does it mean for community and business vitality. You're talking a local community that had 24 workers, now they have 1. How is that impact? How is that bubble cascading throughout the community? Also, it's important to say that autonomy is not just this machine that replaces workers, right? It's, in a sense, I would say it's more of a transfer of skill sets. So yes, you don't need those 24 laborers, but you need that technician that's managing the machine. You need the people that are repairing the machines. You need the people who are virtually running the machines. You need the people who are building and designing these algorithms and machines. So it is, in a sense, we have to understand this from the perspective that we're actually transferring skill sets, hopefully providing higher paid jobs. But then how can we ensure that that is done in a way that it actually benefits these rural communities instead of causing them harm? Similar to what we mentioned earlier, this needs to be factored into education at all levels and life stages to be able to end up with a result that actually not just makes our farms better, but makes our rural communities better and stronger. We talked a lot about broadband issues as well. And we talked about how autonomy, in a sense, is tackling what is now referred to as the 3Ds, right? Dull, work, dangerous, or dirty. Dull, dangerous, and dirty. So that is something that we discussed a lot. So what is our next steps? We're in the process of writing white papers. Our current deadline is April 20th, our internal deadline. We're fingers crossed that we're going to meet it. And from those white papers, we've developed a list of priorities that we're hoping to share with the world and with the community as well, as large. And then after that, our goal becomes next is that where and when will our next Safer Ag workshop be? And that's something we're building and considering right now. And overall, I'll just end with this. We had really great feedback. We had 40 people give feedback, and they really enjoyed the conference. Some of the feedback that we received is that, a person told us that, they really benefited from listening to those in other fields, such as engineering, equipment manufacturing, sales, and consulting. It was good to break out of my line of thinking and see these issues from other perspectives, especially when they have a different priority than my work. Another person, they said they really enjoyed meeting NIOSH representatives and hearing other perspectives. So it's really well received. I think this type of workshop, a type of program is crucial, something that we probably need to consistently do at certain intervals in the future until we at least feel comfortable with these issues autonomy is bringing. And that's it. Thank you, guys.
Wonderful. Thank you so much. Why don't you pull your slides down, and we have several questions from the audience, and I'll suggest that folks continue to drop questions into the chat. And we had the opportunity to send a few of our EAB members to the conference, which was really fabulous because we know this is a really important conversation and topic for Western Ag. So I think what I'll do is I'll start with a question a little bit. You laid out several different technologies that are currently out there, some of which are in use. Do you know where are they being used, and which ones are really in production, being used actively on farms? Are there states where they have been approved and are regularly out working in full production, and others just in testing phases? But what is the different status across the country?
That's an excellent question. First of all, I just have to reiterate that this whole autonomy thing is not just the US, it's global. Like that FIRA conference that we went to, urgence of the conference actually is in France, where they're showing their tech and so on. Where I see the equipment that revolve around orchards, there are actually more advanced. So you can see Gust, you can see Barrow, we've seen them more active in orchard field and stuff like that. I see the technology that's coming next is really now our modular units and stuff like that. That's ramping up slowly. Our smaller units of equipment, a lot of that is still in the research phase and going on. Where do I see it? I don't think I can give you a percentage of where it's focused on directly. I've seen, California itself, yes, they have that ruling against monarch tractors, but from my understanding, they have the Gust sprayers, they're operating there. They have other smaller scale equipment operating there. Illinois has a lot of research focused on the smaller autonomy systems. We actually didn't cover drones at all, but they actually play another role here. I've heard also in research in Arizona and Mexico and in Washington, some in Florida. So it's really, it's all over in a sense.
Right, and there's a range as well. So there's semi-autonomous all the way to autonomous. And so it doesn't all fall just in one camp.
Yes, and actually to me, the more interesting divisions is the type of agriculture. So you see these systems are playing a huge role in orchards and also specialty crops like spinaches and lettuce and stuff like that. So that bed that they were weeding, that was a spinach bed, for example. We see actually a completely different system when it comes to crop production, like our grains, our corn and soybeans. Those are already, I would say, at almost peak efficiency. Like the maximum is just having that driverless tractor. But what's happening there, and I see here in Illinois, is that now it's kind of cool that we're actually going back to older forms of agriculture in a sense. So for example, here at Farm of the Future, they're trying these small robots, which you had a picture there, they are now basically planting a cover crop while corn is still standing. And then when they're harvesting the corn, they already have a mature cover crop that they can introduce cattle to eat, or they can use it in other means. So you could see that reintegration of agriculture that's going on. So I think that's one very cool aspect for autonomy.
That's interesting. You mentioned the weeding in, I think it was the spinach field. And so there was a question about that laser zapping. Is that killing the entire weed plant, or is it just sort of killing the exterior, what's grown up So is the weed going to grow back? Is, I guess, the essence of the question.
That is a great question. I don't know the specs for that. But when I was speaking to them, they were reiterating the importance of bringing those systems early on, just as the weeds are starting. So my assumption, my understanding is that they're going in with the goal of killing the weeds.
Sure.
What percentage of the weeds die, I don't know for sure.
Another question we received was about a stat that you gave. You said, I believe that about 80% of research on new ag tech has not been released, is the way the question came through. And the question is, why is that?
So, no, excellent question. So for that itself, this research occurred just a few years ago, and what they were focusing is that they looked at all the systems that they've heard about, and they're just tracking the progress. So when we're saying 80%, it's not that there's a barrier that's stopping these innovations from reaching the market. Each technology is reaching the market once it's matured. It's more of a census analysis or a survey analysis to say, hey, how far along is this autonomy tech? Where is it? Where is the progress right now? I think the point in being is that the vast majority of these systems are not out yet. So we don't have a full picture or imagination of the capacity of transformation of agriculture that's going to happen.
Okay. Well, that sort of helps me think about the exposure data that you talked about, because it seems like one of the big issues from a safety perspective is that we lack a lot of information currently to assess the safety of a lot of these new technologies. And it's hard to assess anything without that data available. Have you encountered pathways to partner with different developers of the technology, or do you see a path for partnership and being able to obtain that data that does and must exist? Because certainly for efficiency purposes, the companies and developers are collecting all sorts of data. So how might that partnership work?
I think that's, in a sense, Safer Ag in a nutshell, right? The workshop that we're trying to do. Going back to what happened in California a few weeks ago, where it got rejected, there's a realization needs for that sharing. I'm actively talking with industry, and we're trying to discuss, like, how does that go about. There are other modules to follow. I think FAA, for aircraft and stuff like that, has a great module in capturing all that safety data, but in an anonymous way. So there are paths forwards. Industry is interested in this. They are interested in safety. It's just these conversations. We need to basically bring the key players together from academia, from government, from industry, to keep talking to each other for these systems to slowly build out.
And I'd add from farm workers and the people who are actually interacting, the closest to the individuals that are closest to the equipment at the field level.
I think farm workers play an essential role, right?
Yeah.
They know the fields more than anybody.
That's right. I mean, I would say that a simple wrap of duct tape being applied to a equipment that can deactivate the safety features is a pretty alarming capability, and something that is concerning, right? That's all one would have to do. And that leads to a question we received, that some companies are making retrofits to existing tractors to make them autonomous. And so what capabilities might there be to consider the quality of the retrofit that might and sort of monitoring of those changes that are being taken, that are taking place now as those existing tractors themselves become autonomous?
That's a great question. There's definitely several companies, and I can think of a few that are basically took that approach of, hey, you have already existing tractor, let's make it autonomous. There, I'm not aware of a lot of conversation on how to approach that retrofitting, right? Is it I think we're treating them as just autonomous tractors and giving them looking at them from just an autonomy perspective. But actually a really good point that we need to think of. It's not just autonomy function, but also that retrofit. Like I can just, on a more simple concept, we think of ROPS, right? The rollover protective structures. There's a lot of retrofitting there, but you have to make sure it meets that certain standard and certain quality, or otherwise it's not doing anything for the protection of the human.
Yeah, okay.
Yeah,
So
write that as a note.
yeah, that's right. We'll keep track of the questions for you.
Yeah.
Okay, what do we see? Do you know what we see as a background rate of struck by incidents with currently available human-driven ag equipment?
Um,
And I just want to, for the record, say, Bill, you should know the answer to that question.
there you go. That is, I don't know the numbers off the top of my head. I would say, tractors are number one source of injury, and there is quite a few struck bys, but I don't know the numbers on top of my head. I think I need to go back and look at what we have for Illinois.
Yeah. And then a couple, just to wrap us up, we have a couple big picture questions that I'll end us with. Although this one that just came in is another good big picture. So let's see. Oh, there was another one. So I wonder if you actually believe that humans will be able to work alongside autonomous vehicles in the near future. What type of data is needed for regulators to allow the use of autonomous vehicles?
So when it comes to that, we have to keep in mind what does it mean that humans are working side by side with autonomous equipment. You can, for example, you have the burrow where I showed that example. They're working side by side very closely, and there's other equipment there that are very close interactions. But then when you think of this autonomous tractors or that weeder, right? From that perspective, they are working side by side, but the worker is to the side in a sense, operating this machinery on this. So it's really we'll bring it back to the question of what is that meant to be in a sense. At some point in level, I think autonomy is really where we're moving forward to. It seems like that's where all the paths are leading. And where my interest is that for tractors, it took us 70 years to start talking about safety issues. I'm really happy for autonomy. We're talking about it right now. So that we can hopefully address most of these before they reach that mass saturation. So that we're not 40 years down the line still trying to retrofit tractors,
right,
with ROPS and other things.
Sure. And for the question we just received about OSHA, is OSHA the ultimate decider, or are there other regulatory authorities that need to be satisfied regarding, I guess, for safety, I guess it's OSHA.
Well, and keep in mind, a lot of these companies are international companies, right? They're not just operating in the US itself. And even from OSHA, right, you have federal OSHA. Federal OSHA has not raised a complaint against autonomous tractors. It was Cal OSHA, right? So you have levels for OSHA itself. But yes, OSHA is probably one of the main deciders here in the US at the moment. Though there's also, the goal is not to depend on OSHA. The goal is to build standards that are satisfactory for OSHA, that it just says, okay, just as long as you're following these standards, we're happy. I think that's really the industry's perspective. They're worried about regulations that come too soon that basically inhibit innovation in a sense.
Okay, last question. I guess another bigger picture question is, how do we streamline these design processes to ensure that innovation can be adopted in a struggling industry, according to the person who posed the question, while also ensuring that people are safe?
So repeat that question again.
Yeah, how do we streamline the design process to ensure that innovation can be adopted while ensuring that people are safe? Part of what I heard you say is standards, but
Yes. So I think standards are going to play a bigger role for us. So yeah, I think it's really important that there's not going to be a one fit all solution in a sense. So standards play a bigger role, but we have to realize there's a limitation. Big companies are familiar with standards. Smaller companies can't navigate that mess of a standards because from their perspective, they just don't know what to adopt. So it's not just the concept of implementing standards. You have to implement education as well. Then we talked about basically that importance is understanding how these equipment are being used. Because as much as we, like from an inventor's perspective, there's thinking, okay, this piece of equipment is going to be used this way. But once it's on the field, a farmer can easily say, you know what, there's actually other ways I could use this piece of equipment. And it's not the intended use maybe, but it is an alternate use. So that sense of understanding that's important for us to realize that a lot of things you're developing are entering into these alternate uses or misuses. For example, we saw how that LiDAR sensor was ductate. So it's really going to be a multi-track approach where you have standards, but then you need education, both in terms of teaching manufacturers on the standards or teaching farmers on this equipment. What do these sensors do? Like how to stay safe. So I see it. It's like all hands on deck. That's all I'll say.
great. Well, thank you so much. I really appreciate you coming and speaking with us today. This is a topic that we as a center plan to spend more time on because we know it's highly relevant and critical because it is absolutely moving forward, and we know that safety for everybody involved in agriculture is going to require us to be paying close attention. So thank you for being here. Thank you for joining us and speaking, Salah, and I hope everyone has a wonderful evening.